All right, in this first example in section 4.8, we are looking at how to graph a polynomial. Now, we want to think about all of the different behavior and the different information that we've learned about polynomials so far. We've researched and looked at the end behavior for polynomials, so we know how to see what our graph does as it gets further and further away from the origin. We also know how to find certain key points on our graph. In this case, if we go ahead and look at our function right here, which is factored down, we see that we have two roots. This is in factored form. So we have a root right here of -3, and we have a root right here of 2. Now remember, roots are the same things as solutions, which are also the same things as x-intercepts. So we know right here that we have, if we go 1, 2, so we have an x-intercept here and -1, -2, -3. We have another x-intercept here. So right now we know that we have 2 points on our graph. Now we need to figure out what happens in between these 2 points and outside of these 2 points. Now, as we click through, you're going to see some of the information comes up pretty quickly. So I want to just explain what you're going to be seeing in a minute. What we want to do is we actually want to go ahead and plot a couple points between -3 and 2. So what you would want to do is take the points -2, -1, 0, 1, and actually get corresponding y values so that you can actually start seeing what's happening in between these 2 points. So again, I'm going to go ahead and click through, and you're going to see that those points end up getting plotted. Now, we also want to think about end behavior. So remember, in order to determine the end behavior for a function, we need to know what the degree of the polynomial is and what the leading coefficient is. So let's go ahead and look. So like I said, we've got our points -3 and 2, and then we go ahead and if you worked out all these points, you would get these values. Now, you can get, just by these points right here, you can get a kind of rough idea of what happens. Now, we know that 2 was a repeated solution. So remember, in class we talked about if we have a solution that's repeated an even number of times, our graph approaches that value and then just touches it and turns back around. Okay, if this was x minus 2 cubed, then this would go through the x-axis. Now, when it comes to end behavior, we know that, so we've got 3 solutions, so that means this is a cubic function, and our leading coefficient is 1/6, which is positive. So we know that our end behavior is going to behave, first of all, like a linear line because it's odd, and because it's a positive coefficient, it's going to roughly go in that direction. Remember how we discussed in class, they either follow a linear pattern or a quadratic pattern. In this case, when x goes to positive infinity, we know that our y value is going to go to positive infinity as well. And when we go to negative infinity, our y value is also going to go to negative infinity. So that's how we can get the information from our graph. And you'll see all of the stuff we just said about the end behavior is correct right here. Now, again, just to recap, when you're going to graph your function, look at key points that you can find out, either the x-intercepts or the y-intercepts. If your polynomial is not in factored form, go ahead and factor it so you get your x-intercepts. Always remember to create a table and figure out the values for the points in between your roots or your intercepts so you know what your graph is behaving like around the x-axis. And then just use the information that we've learned about end behavior to see which direction your graph should be approaching and leaving as it gets further and further away.